Software Engineering Radio, episode 42, interview with Gregor Hohpe. So let's get started, I guess. So welcome to this episode of Software Engineering Radio. This time we have a guest, which is Gregor Hohpe, or how do you pronounce this for the American audience?
Well, actually, that is how you pronounce it,
Okay.
I would say, worldwide, right?
Okay.
Supposedly.
Okay, great. So before we actually start talking about messaging, which is the topic of today's podcast, what's your background? What do you do, and how did you get into the topic of enterprise architecture and messaging?
Yeah, I work currently actually at Google, but it's somewhat of a interesting and unfortunately a little bit long story how I got into the whole integration patterns and messaging pattern story, which in short, it goes a little bit along the lines that I was working in consulting. And you know that the consulting companies, many of them, when they staff somebody, as long as you heard something along the terms, they think you're like an expert. So what happened was that I used to work with Vitya, and I was staffed on a TIBCO project. And I said, oh, well, this guy knows Vitya, then working with a different vendor tool should be trivial. And they sold me to the client for how many $100 an hour. I'm like, oh my God, what am I going to do? And the interesting part was that after I scrambled through all the vocabulary and the new tools, I realized these things actually do essentially the same thing.
Yeah.
Except every vendor has their own little, spin, their own little vocabulary, etc. So slowly the idea formed that, okay, there must be an easier way to deal with these messaging, process modeling, transformation tools, etc. And that it would be a huge benefit for somebody to have a pattern language or something that helps bring design guidance without every time having to learn sort of the vendor-specific version.
Right, so that's what brought you to writing this book.
Yeah, that's
which is called?
Enterprise Integration Patterns.
Okay, and it's basically about messaging.
Right. So the idea there is, and maybe this is a little bit of hindsight, but the plan is that this would be one of multiple volumes around enterprise integration patterns. A lot of people have asked, why is it not called messaging patterns? Why is it called enterprise integration patterns? And the main reason is the thing is already 700 pages in the first place. At some point, we just had to stop writing, and working on messaging first, is natural. It's sort of the lowest layer. It's sort of the foundation for a lot of integration, service architectures, etc. And I'm now very, very slowly working towards a second volume where we would talk much more about conversation patterns, process, error handling, etc.
I was going to ask, if we consider messaging as the foundation of enterprise integration, what's going to be on top of this foundation? What are the other building blocks of integration patterns, things? As you said, conversion is one, right?
Yeah. So conversation. Sorry. Yeah.
Conversation.
So basically, the way I would look at this is messaging is sort of the underlying architectural style. I mean, that's what brings a lot of the core architectural properties, like the decoupling, etc. Then, of course, you can easily see that the next interesting thing is, well, what if I need to send more than one message? And it's not always sufficient to just like send a message and say, oh, that was my whole interaction. Often you send a message, you get a response, you confirm, you acknowledge, you revise, and this is where the whole topic of conversation starts, which is essentially, rather than looking at one message that travels through a number of different places, which is essentially sort of the pipes and filters architecture, where you can see we really follow a message, which really highlights, in a sense, the sort of architectural property of the stateless, sort of flow-driven, this message asynchronously goes through all these steps, which is nice. But then in the business application, often, as I mentioned, you come to a point where you have a little process or messages go back and forth between the same number of parties. And this is where sort of conversations come in, choreography, orchestration. We're going to start talking about error handling mechanisms, because once I talk more about state, if you think about it, Enterprise Integration Patterns, the book as it is right now, is essentially all stateless. There's a few patterns. We have sort of like these segue patterns where we mention process manager, but it's sort of really just, wait, this is a huge topic, and we just sort of put a link.
It's like the umbrella pattern for the potentially big sub-language.
Exactly, but exactly we stuck with stateless message flow, and then once you have the vocabulary of state, you can start thinking about compensation schemes, error management, etc., etc. And so that would be all the new topics.
Okay, so before we dig into some of the details of those messaging patterns, what's the characteristics of a message-oriented design? Why would I want to do messaging over, for example, let's say distributed objects or RPC style applications?
Mm-hmm. And in the days of service-oriented architecture, that's a pretty common question, actually. The key difference is really in minimizing the dependencies between the systems. And when people talk about dependencies, they often think about, oh, well, I have a registry or something where I look up which service I talk to. And that is definitely one aspect of minimizing dependency. But it goes a lot further. There's dependencies, two kinds of dependencies that I want to highlight, which is a temporal dependency and also a dependency of the interaction style. And I think people too rarely focus on when they talk about coupling, right? We like to be loosely coupled. These days you can't talk anything about SOA or distributed systems without talking about coupling. So when you talk about coupling, what makes coupling are dependencies between systems. And as I said, there's a quite broad range, so like location dependency, and I can solve that with a registry. Technology dependency, I can use XML or whatever to fix that. But where it really gets interesting is sort of the temporal dependencies and the interaction style. And that's where I think messaging really shines, because it's asynchronous, which means that the sender doesn't necessarily, or the interaction style doesn't sort of, inherently require the sender to wait for the whole interaction to be completed. Right? The sender sends the message off, it goes in a queue as far as the sender is concerned. This is reliable queuing, etc. As far as the sender is concerned, the sender is done. This thing is on its way. And you can always say, well, I can make an RPC call and I just have another thread or something, or people sort of use
some kind of middleman object component.
Or like a little sort of delegates and sort of like an event-based, like for example, you can make sort of HTTP synchronous web service calls with various stacks, like for example in .NET, and just sort of get a callback, get a delegate callback when it's actually done. But the problem is that's sort of like an illusion you create at the application layer. It's not actually an architectural style. So true messaging, the style itself sort of has the notion of that the sender is not locked up with the timing of the receiver. And that's what I call, you get temporal decoupling. And it's sort of inherently in the way you design the system. It's not like a little API trick you sort of play on yourself.
Although it's funny because many people say that if you use XML as the message format, you're technology independent and everybody can use it. But of course you have to agree on the semantic content, on the DTD, and on the meaning, and on the schema. It's somewhat the same with this temporal decoupling. What you say is, of course, obviously, I would agree, of course. So, but you don't have a technical temporal coupling, but depending on the business process, you might still rely on the fact that the other side sends a reply message within a certain time box. Right, so there might be that the system doesn't work if the other one isn't up and running because it can't do a sensible job, although it's technically decoupled. So again, this is the difference between technical stuff, right, and application process stuff. So
and that is of course true. I mean, sort of magic, rarely happens. So in some sense, that if the other service isn't available, messaging isn't like suddenly going to make it available, but it makes you think about the interaction between them very differently. And maybe you write the calling application that it can actually do as much it could possibly do without having the response message. Or you even already assume that the request and response go back to the same place. It could move on to another system. There could be a longer chain, for example.
I think that's probably the most important aspect here, that if you use a messaging-oriented style of application development, you think differently, and therefore you design your applications in a way that if the other guy is not available, you don't simply do nothing, but rather you wait. It's easier to wait on a reply message and do a timeout than on RPCs because it's not a technical exception and stuff. So it helps you design systems that actually cope with the other participant not being available.
Yeah, and I always try, very true. What I do, I try to remind people also that in the real world, everything is message-based and asynchronous. It's like, if I want to call you and you're not home, I am not going to sit on the phone for 4 hours waiting till you get back and pick up the phone, right? That would be like the dumbest possible way. But then sometimes I think in the world of computer science, we've become so used to the call stack, command and control infrastructure, or paradigm, if you wish, because it's sort of very comfortable for us to work in. It's predictable. We know exactly what's going to happen. But the real world doesn't work like that. And service-oriented architectures and distributed systems are a lot more like the real world. They struggle with some of the same real-world problem, like you're not home. And so I need to really think about differently. Now, of course, if I need to ask you a burning question, using messaging can't magically make that happen. But I can reduce my effort enormously because I'm not sitting on the phone till you get back, and I don't have to poll, like call you every 30 minutes. I'll leave you a voicemail message essentially, and as soon as you're there, you can call me back. So overall, it's the most efficient interaction. And I think you hit a very good point. These architectural styles, they're very much about changing your mindset. It's the technology only goes so far, but then once you change your sort of mindset, the way you look at the application, suddenly you get a lot more ideas and say, well, I'm building a website. How could this possibly be asynchronous? Because it's like all HTTP on the front end. But then once you sort of have this mindset, a lot of good ideas come. Like, for example, Amazon. They do a very short portion of their process synchronously. Basically, all it says, thank you for your order. It's like it just makes sure the data is logged somewhere. And then everything else is asynchronous. Oh, your bad credit card, out of stock, shipment delayed, your stuff been shipped, thank you, send us some feedback. It's all asynchronous, or people start having more sort of Ajaxy type clients where they make requests and data comes in the background. So I mean, Ajax, I guess, is a perfect example. That being on a web page does not necessarily mean you're completely synchronous. And so I think once you sort of think more, you change your pattern of thought, and this is really what these architectural styles are about. You very quickly come up, like things
different systems,
right? The things that you thought were sort of constraints that you couldn't overcome. Well, it has to be synchronous. Suddenly, it doesn't seem like such a hard problem anymore, and that's sort of the softer side of messaging. But I think it's very, very important.
And if we talk about messaging, then we primarily talk about like enterprise systems, service-oriented systems, because it is interesting to see that message-oriented style of developing applications isn't restricted to that domain. Rather, the embedded folks, real-time folks, use message passing quite a lot. I mean, many embedded systems, even the MPI, right, this message passing interface for high-performance parallel computing is based on messages. So it's a rather ubiquitous concept. But we're talking about this stuff in the context of like enterprise integration, service-oriented architecture. Okay, so I think this is the target discussion.
Okay.
So before we look at some of the more detailed patterns, what's the relationship to service-oriented architecture? At JAU, where we actually record this interview, we're in... No, I'm not supposed to say we're in my hotel room, right?
That's fine.
Okay, I'm gonna edit this out, maybe. So you hosted a track on service-oriented architecture. So what's the relationship between messaging and SOA? Is SOA just messaging with the messages described using WSDL, or how do you see the relationship?
So the track was called SOA, What's Left to Say, and besides just rhyming, it was sort of the theme of...
Oh, I didn't even notice that it rhymes, because I always say SOA.
Right? There's a whole other debate. I was... just told by Patrick that BEA just sent an official memo that it has to be called SOA. So at least in BEA, because I guess it's BEA and SOA.
What's
maybe.
left to say?
Yeah, they didn't want people to call it BEA and SOA, maybe. I don't know. So now we're moving closer. It's SOA, What's Left to Say. But the spirit of the track was very much, sort of what's really in this SOA thing. And I think sort of your question already actually sort of presupposes a very important relationship that actually wasn't as clear in the very beginning, that you already assume that SOA implies messaging.
Oh, I don't. I just tried to ask the question provocatively, right?
Oh,
so
okay.
I don't. Not at all.
Well, you should. I think you should, because in the beginning, people saw SOA very much equals web services, and luckily we are overcoming that. We're really saying SOA is an architectural style.
Absolutely, yes.
And so from that perspective, it's no longer tied to just sort of HTTP and SOAP messages. But what people quickly, I think, started to realize that a sort of RPC-based model for a service-oriented architecture is actually not the optimal style, because
for the reasons we just discussed, right?
Exactly. I mean, we start talking about loose coupling and temporal decoupling, etc. Service-oriented architecture is about A, loose coupling, and B, it's also about a simplified interaction model. And that's where messaging is a very important ingredient, in the sense that if you think about, in the very beginning I touched on this briefly, where we say that coupling is the notion about how much the systems depend on each other, so how many assumptions there are. A RPC style interaction actually makes quite a few sort of requirements. To us it seems trivial because everybody knows what a method call is.
Yeah.
But actually there's quite a bit going on. There's this whole notion that, I have one request and I have one response, and they belong to each other, and the caller waits, and the caller essentially continues after the response comes back. So there's quite a bit baked in there, which, in a services world, we don't want to be so restrictive. And
so in the services world, this is just one way of doing it, and there might be others, right?
It's one way, and in many cases, it's not
the best.
The most suitable way. I mean, that's where all the conversation patterns come into play, because maybe I want to send one message and get a stream of messages back. Maybe I have a more complex interaction where there might be a message later to compensate for something. And I think that's where the notion that really these are conversations made out of messages, A, give you a much better catalog of interactions, and also they get you out of this sort of RPC thinking. If you're starting to think, it's one message at a time, and then they're correlated, we start talking about choreography, etc. And it becomes a much more interesting topic, because service-oriented architecture, to a large extent, is not about what's inside these applications or these services. It's very much about the interaction. And when you really want to focus on the interaction aspect, thinking about it as messages makes a lot more sense.
So if I want to be provocative, I'd say you'd buy the TIBCO bus thing or some other messaging middleware. You send around XML messages for interoperability, and you have some way of dealing with these different interaction patterns, then you have a SOA. Of course, there are all these organizational aspects and business-driven and stuff, but technically this would constitute a service-oriented architecture.
Probably the contract and registry aspects of a SOA, I would still think I would want to have somewhere. So I have some form of discovery, and to some extent using message channels can sort of supplement for that. Because if the right thing happens to listen on the right channel, that's essentially like registering yourself for something. Contracts, I think, are an important ingredient, like knowing and understanding what a service can do.
So what does the contract describe? It describes probably the data structures that go in and out of a service. So it describes the structure of a message, and it also describes the interaction patterns that, like using, for example, protocol state machine, that describes what goes in, what comes out, under which conditions.
Yes, and I believe so, but there are a handful of challenges. The one is sort of a philosophical challenge, and that is, how much should you actually put in your contract? And this is the whole REST versus SOAP debate. But I would say once you believe in contracts, then the contract should actually do a little bit more than just the syntax of the messages.
Absolutely, yes.
It should describe the style. Unfortunately, WSDL isn't very good at that.
Yeah, WSDL is good at nothing, actually, to be honest, I think. Anyway, it's just my opinion.
Yeah, I would say the most useful part of WSDL is the schema, which isn't really WSDL. It's the schema. And there's a lot to be said about the challenges of schemas in the first place. Yeah. But it's not very good to actually describe the interaction. So WSDL 2.0 is actually going to have a pluggable message exchange pattern, whatever you want to call it. Basically, you can sort of specify your own message exchange patterns through URIs, and that was because of the realization that the interaction styles, the conversations would be more interesting. It doesn't have a spec for how you describe the conversations. Essentially, you just make a URI and say this means a certain type of conversation. It doesn't have a rule language or state machine.
Well, this is actually, I think this is a joke, right? I mean, the embedded folks have been using state machines to describe protocols, which are interactions, for a long time.
Yeah, and the choreography guys, you're probably sort of now singing the sort of the misery of the choreography people who are the closest to using a state machine to modeling the conversational state.
Yeah.
So when you look at a conversation, meaning sort of like a protocol for like which messages go which way under which rules, there is a huge battle between the conversation, the choreography and the orchestration guys. There's too many words with C in the whole service
choreography
story.
and orchestration, same thing, or?
No, very, very different. I've seen heated debates.
Okay.
You don't even know. It gets very entertaining at every sort of web service event. There is, as soon as you put a choreography person and an orchestration person together and, serve a few beers, it gets generally very interesting. The fundamental difference being, and the funny thing is that they are it's like a dualistic view of the world, so you can discuss forever.
Yeah.
But essentially, the choreography people look at the conversation state. They say, we don't care about the endpoint so much. We really just want to observe what messages go back and forth.
Mm-hmm. So like a middleman who watches both?
Exactly. He doesn't have to be a middleman that he's plugged in, but it's more like the observer. Yeah. It's the observer and say, here's the rules about what messages go, and I could have more than 2 endpoints, for example, and I sort of watch that goes on, and I have rules about what goes on, versus the orchestration folks very much come from the perspective of a service endpoint, typically a service provider, and they say, here's an abstract process that has send and receive actions in it.
So that's the protocol state machine, classically.
Yeah, there's a protocol state machine from the viewpoint of one endpoint, of a single endpoint. Yeah. And you can see that they're very sort of dualistic. I mean, the most simple sort of request response, again, is the process would look like, I have a beginning action. My process begins, I receive a message, I perform the computation, and I send a correlated response message. And so you have like 3 actions in this BPEL process, maybe whatever you use to make that orchestration. Yeah. And in case of BPEL, for example, the business process execution language, this is actually also described through a WSTL document. One of their processes is always described externally through a WSTL document. It manifests itself as such. So it's very clear it's a service. Yeah. In the choreography world, there would be one conversational state, essentially, with a single conversational state is I'm waiting for the response, and you could sort of describe, essentially, I expect one message to go, and now I'm in this state, wait for response, and then once a message comes back, the conversation ends. So it's very similar, but it's sort of different viewpoints, and especially once you start talking about having more than 2 participants, getting out of this consumer-provider model, then the choreography, is a nicer way to describe it. Where it gets interesting is that sort of intellectually, I like the notion of the choreography. The problem is the standards are nearly far enough along. There have been many failed attempts at sort of doing more in this world. There's like the WSKI, the web service choreography interface. There's sort of many stalled and failed attempts because I think that just specifying the conversation is a relatively abstract part. So you want to go and build endpoints. So having like an orchestration where you have a little process and there's tool and people is pretty far along as a spec as well. You just put this together and you have it and it runs. Versus so intellectually the choreography is appealing, but it's always had a very hard time getting mainstream adoption and vendor support. And that's where those battles happen.
Mm-hmm. So now we talked a lot about the book you didn't write yet, which is interactions and conversations and choreography and these things.
But of course, that's more interesting, right? No, just kidding.
Yeah, I know that.
For me, it is.
Once you finish the book, and you should actually, tour the world and promote it. You're so fed up with the content that you don't want to see it anymore. But still, I'm sorry, but let's go back to messaging a little bit. Yep. So, can you? I mean, your book is a pattern language, right? So it contains how many patterns?
65.
60. Oh, quite a bit. So can you? I mean, we're not going to recite the whole pattern language now, but I think we should do 2 or 3 things. One is you probably have chapters or something, so areas of interest which are covered by several patterns. So maybe just cover these different areas, and then we should maybe pick up 4 or 5 of the most important patterns in like this topmost area or something. So what are the main areas of concern in messaging systems for which your pattern language contains patterns?
Yeah, and it's good to actually go back to messaging, and the way you phrased it, I quite like it because it sort of highlights the fact that messaging is the foundation for all this other stuff. We can talk about the other stuff a long time, but it all comes back down to fundamentally message-based interaction. So what we did is in the patterns book, and patterns has become sort of like a word where if you want to boost your book sales, you stick like the pattern word in the title. And
you think that's still true?
I think we just maybe overcome it. I would say in the last 2 years, it was very popular to have pattern on. And I think people started to realize that, the patterns are not all what they're cooked up to be. So I think we may be slowly coming back to patterns be real patterns. But I think I like your question because the language aspect is one of the key properties that people tend to underestimate. A pattern isn't just like a pattern. There's a very important reason patterns have names, and they have names so you can make sentences out of them. And when you make sentences out of it, they form a language, and they're supposed to have sort of somewhat of a common structure so you can make meaningful sentences. So we did that, and we thought very carefully about how we structure our language. And if you even think about back to Gang of Four, there's some structure. There's creational patterns, and there's structural patterns, there's behavioral patterns.
Although they're not a language, right? Because they don't build the whole. So GOF is like a collection of patterns that are packaged into different concerns or aspects, creational, behavioral, but they're not a language in the sense that if you apply them in some sequence or in some way, they build a consistent whole. Yours is different. It's a language in the sense that if you apply those patterns, you create this whole big messaging infrastructure, right?
Yeah, maybe you should have a session with Ralph Johnson where you tell him his book is not a pattern language, saying might go an interesting way.
But I think the pattern community agrees. Maybe Ralph doesn't, but the community probably agrees that it's a collection of patterns or a system of patterns, but it's not a language in the sense that it builds this whole, right? So, anyway,
I think what is unique,
pattern theory,
maybe not unique, but what is interesting in our book is that we structured it along a set of root patterns,
right?
And then we drill down from each root patterns. And the root patterns basically give you the key pieces that you essentially need to build one of those solutions.
Right.
And that's where you're right. I think the structure is quite different. And in the back inside cover of the book, we were able to basically show a sort of prototypical messaging system where you have a sender, a message, it goes on a channel, there's some transformation, there's an endpoint that receives it, and then there's sort of a little bit of system management monitoring on it. And it sort of turns out those are actually like the root patterns, like the prototypical picture of what this thing, all the pieces you need. It's a little bit like a shopping list and say, more likely than not, I will need those 6 things.
Okay, so what are these?
They became the root pattern. Yeah. So basically what they are is we have channel patterns, because I need to have a messaging channel. We have message patterns, because I need to put a message on there. Then we have routing patterns, because I need to get the message to where it actually is supposed to go. We have transformation, because more likely than not, the two endpoints have different data formats. Then we have endpoint patterns, because actually the message has to be consumed, and this is sort of the whole event-driven asynchronous message thing sort of hits the synchronous object-oriented application, so it's an interesting topic as well. And then we have systems management and monitoring, which is something that seems more peripheral, and say, well, I don't need that really, it doesn't really make the messages go, but it's something that's very close to my heart, because these very dynamic, loosely coupled asynchronous solutions,
right. If
you don't have decent monitoring and management, you very quickly get yourself into trouble, because essentially what you do with these loosely coupled dynamic solutions, you defer a lot of the decisions to runtime. Like a lot of things that in traditional designs you would sort of hard code or bake into basically at coding and compile time.
Yep.
Now are very dynamic and flexible at runtime. You can reassign channel names, reroute stuff, put on more nodes, whatever you can do. So when you make that decision, you get a lot of architectural properties. You can scale and loose coupled and whatnot you have. But it also means that you need sort of equivalent tools, because you don't get syntax errors anymore if you mess up the type, or if your messages don't go the right place, you don't get a stack trace, right? It's like you have to have a whole new set of tools, and that's why we made systems management and monitoring a first-class pattern in the book as well. And then each of those things have a root pattern. So there's the message channel, there's the message router, message transformation, there's the endpoint, and then there's sort of systems management. And then each of those basically blows up into a whole chapter where I say, okay, I know I need a router, and then I sort of go to the chapter of routing, and then I have sort of 11 or 12 message routing patterns, and I have sort of a little catalog and a little we put even together sort of a little decision matrix where you can sort of help decide which one you want to choose.
So then typically these sub-patterns under each of these root patterns are alternatives that should be applied in different contexts, or so let's briefly go through each of these categories or root patterns and briefly discuss what kind of alternatives there are in each of them. So if you say there is this root pattern channel, what kind of variability is there, or what's the different alternatives with regards to channels? Maybe I thought maybe there's some persistence channel, there's transactional channels, there's probably channels that are secure, or what's the kind of variability here?
Mm-hmm. Yeah, and I think generally what you described, that there's a root pattern and from there going to alternatives, is generally correct. The one thing I do want to highlight is that patterns are not sort of painting by numbers. Yeah, it's not where I sort of just go down some checklist and magically I arrive at the one single answer.
Yep,
the very reason we use patterns is because that's how software architecture does not actually work. So you have this list of ingredients and they have a certain sweet spot, but you can always combine or you can always find something new. So it's not like you go down this checklist and you find a perfect one.
Yep.
However, what it can do, it can help you sort of choose what are things you need to consider. So you mentioned channel patterns. So the things that are interesting about a channel are the semantics of the message propagation and consumption. And this is where I choose, in this case, it's a relatively immediate choice between two options, is point-to-point or publish-subscribe.
Right. Okay.
Right, so if I have multiple subscribers, do they compete for one message and it's guaranteed the message goes only one place? Or is this I send a message and any number of subscribers will get it? And this is, just sort of have a mini sidebar here. This is where the patterns really help in a sense that you see that these are two fairly different choices, but the patterns can really explain a lot of the subtleties and the nuances. So, for example, a publish-subscribe channel has a very interesting property, which is adding new consumers is side effect free. Right? It doesn't impact the consumers that are already there, versus on a point-to-point channel, adding another consumer takes messages from the first one.
Yeah.
So it's good for scaling because you have multiple consumers that are of the same type. But if you want something sort of more event-oriented, you can't just like add a second one to it. True. You would actually have to put a T on, which is one of our other patterns.
Probably a routing pattern, right?
Yeah, it was exactly where you like one channel goes in and the same thing goes on two output channels. You manually build it, but so it goes into a lot of those nuances. But back to your original question, so it's it's sort of the semantics of the message propagation and the subscription. Then it's inherent properties of the channel. So it's durability, for example, is an important one. Is this persistent or non-persistent? And then we also have channels that for special uses. So, for example, you would have an invalid message channel. So, for example, if a receiver receives a message that it can actually not process, rather than just tossing that message, because then we would never know that this actually happened, or trying to log it in some log file. Well, we are in a distributed message-oriented system. Why not use messaging to represent that and route that message on a specific channel that's designated as a channel for messages that could not be processed? So this gives you a good choice about, and you can combine some of those. Like, for example, I could have a durable point-to-point invalid message channel, if I want to.
So let's take a brief look at some of the alternatives with regards to, I think, message was the next one. Mm-hmm. So what are the points there?
Yes. And of course, it's again one of those topics that sounds a bit more trivial than really is. It's like I have to put a message on the channel. So, well,
who had thought that?
Yeah, right? Exactly. How hard can that be? And that's why some of our original patterns are more just to form the vocabulary, right?
Yeah.
It's like the message root pattern itself is not some incredible insight that we had. It's like, yes, a message goes on there, but what we try to highlight is what actually makes a good message. Messages are not objects. They're often document trees, but they don't even have to be. Like in a typical world, a lot of it was name equals value. So different structure, no pointers, different type system often, etc. So there's a lot of subtleties, and even I wish that we would have a bit more about what actually makes a good message design. Right? I'm still looking for the book that says, hey, here's a good message and here's a bad message and here's why. We quite honestly didn't even get to that point either. What we did, we focused primarily on sort of what is the message used as. The nice thing is about that the patterns don't always just have to describe a technical solution. But the patterns can also focus very much sort of on the intent. So we have a event message, a document message, a command message.
RPC message would be a command.
Exactly. Is a message that is intended to like instruct the other end to do something, and the conversation could still be more than just plain RPC, but the idea is it's like I'm sending a command versus I'm sending a document, like here's an order or something, versus I'm sending an event, which is like an order was placed, but not necessarily do I have the order in the message. So that gives you again some choices, and then on top of that it gives you important, what's often considered header fields, like another term is often used, like out of band
metadata.
Out of band metadata. Basically it's all the stuff that is very useful in messaging system, which is not the actual payload. So that's where we talk correlation identifiers, right? We are living in the land of asynchrony now. So if I send 3 messages and 3 come back, it would be a very bad assumption to assume that the 3 that come back are in the same order as the 3 I sent. So I need to correlate.
Correlation identifier is also known as asynchronous completion token in the kind of more technical world, right?
It is very, very similar in idea. I would say the completion token has a bit more of the application view, where I sort of kick off a process and I hold on to this token to store the state. The message identifier is essentially the same larger pattern, but sort of it focuses more, well, here's the thing I stick into the message, which is sort of indicative that we focus more on the interaction than the application. But of course, the forces and the thought process and why we do this is essentially identical. And a lot of applications, when they use a correlation identifier, they actually use it to keep their state, etc. So when it comes back, they use it exactly like an ACT. You pick up back your state. However, in our world, we go more quickly to sort of like the conversational aspect, where we look at, this identifier is in this message. Now, can we pass this identifier through a whole conversation that goes through multiple stops? And that's where the emphasis is just
it's different,
slightly different, but same fundamental forces. So we have things like return address and correlation identifier, etc. So that gives you a good idea of what should be in a message header. And it turns out that most commercial messaging systems, any JMS implementation or any typical video web methods kind of thing, the WS addressing, etc., they all have these kind of patterns already built in, because once you have some form of asynchronous interaction, you really need to have some of those core patterns. But it makes sense to have a common name. It makes sense to sort of describe why they are so important. And also, it's important to say, well, what if I don't use those fields? What assumptions do I bake into my design? So if I say, I'm doing something very simple, I don't need a correlation identifier, because I just like send one message or something, which is probably fine and good. But then the pattern reminds you, it's like, well, here's the assumptions you just made. Right? The assumption you just made is that you have order guaranteed channels, and that you probably only have a single consumer, because as soon as you have more than one processing unit, they run in parallel. You build a distributed parallel system. Order is the first thing that sort of goes out the window. So essentially, you precluded yourself from scaling out. And people go like, oh my God, I didn't mean to do that. And so the pattern is very nice, even though the pattern itself isn't like rocket science. It's like, correlation identifier, most people can figure out what that is. But once you sort of highlight people, here's the assumption you just baked in by not using that field, and people go, oh my God. So it's nice to remind you of the ramifications of not using something. So you can use the patterns in reverse.
That's why patterns that have somewhat like an obvious idea in them are still like 7 pages long, because they discuss all those trade-offs.
And I think that's why patterns
are useful.
They're relevant, even though the solution itself is known and often built into the platform. The discussion and reminding people is enormously valuable. I mean, we had no problem filling 700 some pages with what we believe is interesting stuff on a field that I would love to be much better understood, but quite honestly, a field where there's a lot of vendor implementations already. I mean, it's not like research. I mean, it's like, that stuff is out there, it exists, but there was a lot that was left to say. Exactly for that reason, and that's why we chose patterns as the format.
Absolutely. Okay, let's look at the routing patterns. What is there specific? That you mentioned the T thing before, like one channel, separates into 2 channels.
Mm-hmm. And the nice thing about messaging is that you can find a lot of real world analogies. So the T is essentially like your little double your socket multiply, right? Where you can put two power plugs into one, or you split your video signal in two, so you can watch in your bedroom and the living room kind of thing. Yeah. So some of the routing patterns are very much like that. It's almost like schematic type stuff. The message goes in one channel, it goes out on two. Yeah. But routers can be pretty complex. So there's a lot of what we do is around, again, the semantics. So is this router going to send a single message out? Is the router going to send multiple messages out?
So if you have this T thing, does it decide for each message where it goes, or will it like the electrons, right? Or photons actually go through both of the channels?
The T is like the stupid photon; it just goes both sides, and so it's good. It's like a splicer. You sort of we call it wiretap as well, actually. So because you put it in the mainstream and you parcel off messages.
The NSA pattern.
Yeah, don't say that.
No.
Yeah, but it's like the little splicer wiretap. Other patterns are much more intelligent about where things go, and the key pattern there is the content-based router. So it's something that looks at the content of the message itself, and based on that decides where the message goes. Now, there's still a distinction that we have between a content-based router, which sends the message to a single place, versus a recipient list, which sends the message to multiple places. And you start seeing there's sort of a nice spectrum. You're saying, where's the difference between a recipient list and a publish-subscribe channel?
Right, because that would have been my question.
Doesn't a publish-subscribe channel already do that, right? It does send some messages. And that's, again, where the patterns are just a very good format to discuss the nuances. In a publish-subscribe channel, you generally have a common sort of, element, big word use, open bracket, ontology, closing bracket, big word use. Yeah. You have some sort of common ontology or structure that defines where all receivers have to express what they're interested in. It's usually a topic space or the name of a channel. It's like, I'm interested in channel ABC or DEF, or I'm subscribing to this topic, which is called, order.new. something rather, some sort of hierarchy. But you have to have a common agreement on this languages of who subscribes to what, and the subscription is very much at the control of the consumer. Mm-hmm. The recipient list is an active routing element that sits in the middle, so it incorporates its own language. The consumers can't really say much about it, but it has many more degrees of freedom of what it wants to route by. So it could say, the textbook example is, if the order comes in for less than $1,000, it goes here, and if it's more than $1,000, it goes here, but it could also decide to send it both places. Or sort of certain escalation schemes, or the topic that we have, the example we have in our book is you're making a request for a loan, and there's three banks. There's like sort of the premium bank, there's the all-around bank, and then there's the loan shark. And it turns out that each bank only likes to service certain customers. Yeah. So our router sends it to multiple banks because you want to get the best quote. But the banks require us to kind of pre-filter a little bit because the bank doesn't want to deal, the premium bank doesn't want to deal with the decrepit customers. Yeah. So we did that as an example, and it turned out that the loan shark was actually the bottleneck in the system. And the reason the loan shark became the bottleneck, because the loan shark takes everybody, but rarely does it give you the best rate. Yeah. Right? So we optimize our recipient list to say, go to the loan shark only if you don't have another destination. Right. And so immediately these business rules in there optimize, and the system throughput, we went to a multiple. We used sort of random data to just feed it, but I went to a multiple because the loan shark queue was just always backed up. And so you can make very intelligent routing decisions, and that would be something that a pub-sub channel cannot do. Right. Because it's completely side effect free. You cannot say, because this message also goes to premium, which I know they're going to give us a good rate, I don't even have to bother to go to loan shark. Right. So very important subtle difference. And there's like a dozen of these sort of different routing patterns, and Okay. Look at the website.
Which the URL of which we'll put into the show notes, of course.
Yeah, EAIPatterns.com. Okay. Search Google for integration patterns, and you'll be good. So.
Yeah, you probably hacked the Google search algorithm since you're working at Google, right? So, what are some of the endpoint patterns? I can't imagine what these would be actually. Mm-hmm. So, like the API towards the application.
I know API is a little bit of a bad word in the patterns community, right? We like to distance ourselves from the people who talk about APIs.
Okay.
Yeah, I'm just sort of, a little tongue in cheek here.
Yeah.
But now what we find the interesting part of the endpoint is that this is where the document-oriented asynchronous stuff hits the object-oriented synchronous stuff.
So you have to map it, and that's what I meant by API.
Yes. So it's a focus on how you actually get the message.
Right.
So there you have the choice between a polling consumer and an event-driven consumer.
Yeah.
It's basically how far into your app can you continue the event-driven nature of this, and the short answer is the further the better, mostly, but no pattern is ever universal, so there are fine reasons where you like to poll. And then it has other things like a transactional consumer. Transactions and messaging are a big topic of controversy on occasion.
So it's, you say it's not enough if there is a transactional channel. You actually need a transactional endpoint, so you have some means of controlling the transaction, like beginning and ending the transaction. Is that what you're talking about?
Correct. So the most important thing is when we talk about transaction and messaging is that in loosely coupled system, essentially you don't want your transactions to span multiple systems because the transaction is going to be short-lived.
But isn't that the whole point of a transaction?
Yeah, in a sense, yes and no. But I would say the point of a transaction is pick your scope.
Okay.
It is the point of a transaction within the scope that you chose. So in a messaging system, you choose your scope of doing a business action and sending a message as a result.
Right.
And then it's the role of the messaging system to make sure that message doesn't actually get lost. I mean, it's just like sort of a database transaction. The role of the database transaction is do some business functionality and get data into the database and then make sure it commits or read something from the database, change according to your business logic, and then update the database, maybe multiple tables, and then make sure that's consistently committed. So in a messaging world, we keep the same local context between the application and the message. So very, very common transaction scope is receiving a message, performing a function, and sending a message. Because that's how you ensure that between, if you have guaranteed channels, if in your application, and this is what a transactional consumer does, it will open a transaction, read the message from the inbound channel, do its work, and then send the message on the outbound channel in the same transaction, because here we don't have any issues. It's a local application scope, and then commit or roll back.
So it's not about that the endpoint controls the transactionality of the channel, it's rather that it's like an XI resource, right? So that the client can be a part of the transaction and do its work in a controlled, bounded fashion.
Correct. So the transaction is the client. So when you say XA, though, I want to be careful. Let's say if I have a publish subscribe channel with 10 possible consumers, the transaction does not span the 10 consumers.
Right.
The transaction deals with each consumers and the reading of its message and possibly the sending of another message. So the transaction context is very application focused. Not across different channels or consumers, because that would be sort of the antithesis of
loose coupling,
and message event flow, etc. You lock everything down again.
If you needed to coordinate those 10 folks, then you'd have to do this on an application level. So you'd wait until all of them send a positive reply, the ACK message, and then you'd, on the application level, say, okay, business transaction finished or something.
Right, and of course, in a business transaction, I mean, there's sort of the prototypical example of the bank account. You send a message to this account and this account. Probably don't really do that, but that's sort of the example that always comes up is like, well, how do I ensure integrity? And this is where you hit the world of different error handling strategies, compensation and retry, etc. So you usually try to find alternatives, because transactions and sort of loosely coupled messaging just don't mix at the same level. As we described, they mix in a sense where you have the transactions around the channel endpoint and the application, but the overarching messaging architecture doesn't like transactions of a large scope, because it just goes immediately against the temporal decoupling, the asynchrony, etc.
So did we cover all of the root patterns? I'm under the impression that one is missing, but I can't remember. Transformation? I'm not sure one was, I think.
There's two that we haven't covered, the transformation patterns. And so the root pattern I mentioned beginning, one of the nice things I believe we did is sort of having these root patterns for language. The root pattern is a message transformer, and again, it's not a huge surprise that sometimes you want the message on the other end to look like differently from what you put in. And then we have a couple of subtypes. Like one is an enricher, and again, we talked about a little bit that the patterns don't necessarily mean a different technical solution, but they express the intent. So a message transformer is something where it's very generic. It's just somehow it gets transformed. The enricher much more expresses the intent that the original message was missing something that the other end wants. So I send a message in, it goes to an external resource of sorts, and then it sticks additional information into the outbound message. The external resource could be like a real database or application where I retrieve information, or it could be like a system resource, like a timestamp. Maybe my message is missing a time, and so I can just do that. But the idea is the message gets sort of bigger on the other end. And often, your message transformer might be doing a little bit of both, but that's where the patterns allow me to express what I think is the more important property. Is this more important that, I'm augmenting it, or do I just say, just like a general transformation, it's just whatever. And then we have the same thing where you can sort of select pieces. Let's say I have a very large message, but I actually don't want to transport all that, so I reduce my message, and that's sort of the reverse of the enricher. And you can express that the main intent of this transformation was to actually select a sort of subset of information. And we have a few other patterns. We have something called claim check, where you store the message data and basically just pass a key on. Okay. And then you can pick it up later. And so there's like about half a dozen of those.
So one aspect of loose coupling is probably also that although you have this temporal decoupling and the API and stuff, you don't want to induce a high degree of coupling as a consequence of having to agree on the same data structures. So one of these transformers is probably useful to, like the adapter pattern in Go, right? So you send one format of message to this thing, and it converts it to some other schema, for example, that is the content is basically like the same, but it's formally differently expressed. So I think this is a very important aspect of transformers, to decouple the otherwise appearing binding between endpoints because of their agreed upon data structure.
Yes, and it's very, very important to realize that these kind of dependencies and these kind of bindings can happen at many different levels. And one level is the data format.
Right.
And so there's strong assumptions baked in. And there's a couple of things I can do. Again, the patterns can't offer any magic, but the patterns can give me a good catalog of what at least my reasonable choices are.
Right.
So in case of the transformers, the main thing is I don't make the problem go away, but I move the problem in a specific entity of my choice.
Exactly.
Which is outside of the systems. I know where I'm dealing with this problem of data format. And also, quite honestly, often I use a language that's more suitable to data transformation. Right. Now, some people would argue whether
technically
whether XSLT is suitable for anything.
Oh, yeah.
There's a lot of debates, but essentially it is, for better or worse, is a language that only deals with transformation. So by me pulling this out into a separate entity, I have more choices in terms of implementation, for example, and I very specifically sort of incarnated the problem in one place rather than having lingering in the two endpoints.
Separation of concerns was always a good idea.
Yeah. So I mean, as I said, no magic, but a good set of choices, and at least I have my concern, my problem represented in one spot. And you're exactly right. The message transformers do that, but they go beyond that as well, because let's say the question is always, should I put all my data on the channel and let the other side pick, which sort of protects the sender but is rather inefficient, or should I only send the information that I know the receiver really wants, which is a stronger form of coupling but a lot more efficient.
Right.
And that's where I was saying we get into this whole idea of so the message selector or the enricher, etc. And we can play very much. And this is where the intent of the patterns is important. When I say, this is really sort of something that shrinks the message, because I make a bit more assumptions. I have knowledge now about what the other end needs, but I actively put this element in because I got to get rid of these huge messages. And so I use that pattern and that icon very specifically to represent that intent, as opposed to, the field was called last name, but it really should be called name, which is like a generic transformer. And that's where the patterns, and especially we made little icons for all these patterns.
Right. That's actually quite nice.
Suddenly become much more expressive. If you look at a system architecture diagram, it shows, XSLT transform here, but it tells you very, very little about why the transform was made and what the intent is.
It talks about the technology instead of the concepts, which is always a bad idea.
Correct. And with the icon, I can now, even though we only have like half a dozen of these for transformations, some of the core more intents I can very quickly express, and they have these cute little pictures where a little message becomes a big message, or a big message becomes a little message, or sort of the transformation, so you can tell.
Did somebody come up with a tool where you can draw these like schematics using your icons to build your messaging infrastructure interactively?
You can draw it. So somebody made a Visio template.
Cool.
So that was actually in a student reader and did that very early on, and it's downloadable from the website.
Cool.
Somebody just ported that into OmniGraffle, I believe, for the Mac platform.
Yeah.
So people do it for just design
documentation,
drawing tools, I should say. There was an interesting blog entry and experiment that I did. Patterns are not components.
Oh, I agree.
Right? But in our case, we can cheat a little bit because the composition model of messaging is so simple, which is essentially like put a line between those two boxes,
right.
that you can get pretty far for, let's say, I would say at least sort of educational purposes by making components for each patterns and chaining them together.
Right.
It has its certain limitations, like I already said about a channel. Yeah, you might pick a sort of point-to-point persistent, invalid
like
message channel.
Of the thing.
So you can't really compose those. But I can put a router and a splitter and an aggregator and a transformer.
Yeah.
I can chain those together. So what I did is I actually built a little toolkit, which it's each thing is its own individual process that talk over MSMQ. It's already pretty low tech, and it's downloadable from the website as well. And you can sort of build little solutions out of your patterns.
Nice.
The reasons, of course, that works, or the reason I could cheat, if you wish, is like I fixed all assumptions. So this thing only runs on Windows, .NET, MSMQ. XML messages, right? Like I fixed all the other parameters, and I picked exactly the kind of patterns that lend themselves well to doing this. And there's a third main reason it works, because I resorted to other programming languages to absorb the variability points. Like, for example, my transformer pattern component. It takes an XSLT transform. Or my splitter takes an XPath expression. So essentially I have a whole programming language behind it. And that's kind of like, I sort of just move the problem. It's like, oh, I have this one common component. It's like, no, it's really just kind of like an interpreter for a whole new language. So you got to be quite honest there. And I highlight that because there's so many vendors going out there and say, oh, this only requires configuration. There's no programming here. And then you see these XPath expressions. It's like : : ancestor, sibling.
It's a domain-specific language for data transformation, right? So it is programming.
Yeah, of course, and it's sometimes tough programming. It's very functional, expressive. It's hard to debug, and so that's why I highlight the fact I was very honest that I cheated there and said, hey, I moved the problem from one language into another. But so to some extent, the messaging patterns are unique in that you can kind of make components out of them, but it's more, I use it purely for educational stuff. So people have done this mostly for drawing tools, which I think is a very good use of it.
Although it would be an interesting experiment to actually use model-driven development to generate system configurations and MQA series configurations, for example, from these drawings, which is, from the generative point of view, no problem. And that would give you, if in a big enterprise, it would give you this like composer for managing your messaging infrastructure. Could be a nice experiment.
Yes, you can definitely generate based on some property. Intent is something that's not very well translated into code. So
you would have to specify these things in the model. You have to represent your intent in some formal way.
What is quite useful, we've done a lot of visualizations. So with the same toolkit that I just mentioned, where you put these patterns together, you can actually draw your messaging diagram because it uses the control bus pattern, which is part of the systems management patterns, the last ones I mentioned, and the last category actually. And so it knows who sends messages where, and it makes you a message flow graph. And for example, what you could do there, you could annotate your individual components, say, I really am an enricher. Like, my purpose is really to be a message enricher. And then you could feed that into this automatic diagramming tool, and it could pick the right icon. Haven't done that yet, but that could be a quite useful application where sort of the pattern, iconic language, and the actual system correspond a bit more. So that, pretty much completes the category. Systems management is the last one. And it's all the things that deal with stuff that is not the main flow of traffic. And initially that sounds like, well, why would I not like, why would I want to do something else except get my messages from A to B? Because that's my whole purpose of my messaging system is to get data across.
Yeah.
But once you start to realize and look at any other protocol or system, look at the telephone system. There's a lot of out-of-band information in the telephone. The best story was always the Captain Crunch story, right, where they used a specific tone combination to indicate the end of a call, and there was obviously out-of-band information, but unfortunately they used in-band frequencies to do that. So there was a little whistle you could blow, and then the phone would stop collecting toll. Right? So that's
but the connection was still there.
Yeah, exactly. Because it was.
I didn't know this.
Because it wouldn't actually physically hang up. It just sort of basically.
Yeah.
So you could go to the phone, dial a number, and blow the little whistle, and then the thing would go. So that teaches you a good lesson about separating out-of-band and in-band data.
Yeah.
But any sophisticated communication scheme, I mean, TCP/IP, there's the routing information protocol, etc. There's a lot more packets going over your network than just application packets.
Yeah.
And messaging, the same thing. You kind of want to know what's going on. So, for example, a control bus, where applications, besides just having application-related messages, they also send maybe statistics or update messages, or maybe they can get controlled. I have a little example in the book where you use a router to do active failover. So you don't want to do competing consumers, for example. So generally failover you can get very easily by having multiple competing consumers, right? So if one of them goes away...
He wouldn't pick any message anymore.
Right, the other guy does all the messages and it gets a little bit slower, but the beauty of that kind of architecture is you still end up in the best situation you possibly be in, right? Because it's like one goes away, the best you can do is route them all to the other, and it's sort of automatic. But there might be situations where I don't want to do that, because let's say I have a cheap provider and a premier provider. So normally I want to run on the cheap provider because I get volume discounts. And only if that guy goes out do I want to switch over. So that's where systems management is really helpful. So you can monitor a flow of messages, or you can ping components.
So you notice that the one actually got down. Right,
and I know that the one goes down, and I switch the router over, say messages now go to the other one, and I have a little console with a little picture. Right. So this one goes red, and the little router actually redraws the router. So it's kind of cute. You can play with the icons where it's like someone like a mini railroad, model railroad. The messages now go here and they go there, and that's what a lot of system management is about. It's visualization, control, knowing what's going on in the system,
giving the administrators the relevant information, not all of it.
Or even also putting administrative information into the message, like tracking where the message has been can be quite useful when something goes wrong for logging, because you don't want to keep too much global state. So a good place to keep your state is in the message.
Right.
You want to keep it in a special part so you don't end up with the Captain Crunch problem. So you want to separate the application payload from the header. But then it could be quite useful, for example, the invalid message channel, to know where the message has been and have a history. So we call that message history. So the message carries its own history. And for example, the good old TIBCO Active Enterprise actually had one of those patterns built in. And I think it wasn't used nearly enough, because they had these magic fields, but it was really hard to understand what you would really use it for. And that's, of course, where the pattern comes in and says, well, that's what you really use it for. And that's about 65 patterns. There's a lot in there. I'm sure I only mentioned even half of them by name.
No, but I think this was actually very useful, and it was a bit long, but I think it doesn't matter. So I think this. Is there anything else you want to say to our listeners? Leave them with any pearls of wisdom before we wrap up this episode.
One of the questions we often get is in my specific case, I can't use messaging, or messaging doesn't solve problem X. And obviously the answer there is, of course, messaging doesn't solve all problems. I mean, basically what we try to do is give people sort of another tool in their toolbox and say, hey, there's a lot of cases where you can use this. There's probably more cases than you would initially need.
Right.
And the good thing about writing patterns book, as opposed to being a vendor, the vendors always make you believe that their product applies in virtually every and any scenario, versus for us, it doesn't make a difference. We can honestly tell you, it's like, hey, here's where messaging actually works for you, and here's where messaging doesn't. And the patterns are very honest.
So you're saying it doesn't matter whether the people buy the book, read it, and see that it solves their problem, or whether they buy the book, read it, and it doesn't solve their problem. As long as they buy the book.
Yeah, just make sure they buy the book. Yeah. But I mean, all joke aside, a lot of the information is on the website, so there'll be all patterns on the website. You can download the icons. Obviously, not all the book text is on the website. Right. So, but it's you can definitely try before you buy. So we try to be. I mean, we believe patterns is something very community oriented.
Absolutely, yeah.
So that's why we like to share.
Okay, Gregor, thank you very much for being on the show. I think this was a great episode. Thank you.
Yeah, thank you. I hope people have the time and patience to actually listen to the end. So.
We have good feedback also for longer episodes, and in worst case, we will make it 2.
Okay, sounds good. Thank you.
Thanks. Bye. Thanks for listening to Software Engineering Radio. If you want to get more information about Software Engineering Radio, or if you want to give us feedback, please go to our website at se-radio.net. You can also contact the team at team@se-radio.net, although we prefer entries in our comments system on the website so other people can see what you think. Software Engineering Radio wants to thank Henning Pauli for the intro and outro music, as well as Libsyn for providing the bandwidth. This episode of SE Radio, as well as all other episodes, is licensed under Creative Commons license. See the Software Engineering Radio website for details.